I should say to start that I'm glad that I work with my wife. I should also say that I'm not anything about you personally, Maria, but just I don't think my wife and I could handle that for the time period for 11 years. I thought that I should also thank the Brazilian organizing committee for inviting an international speaker in the event. And I thought that I should also express my appreciation to the organizing committee for not reneging on my invitation to present despite the bad behavior of the U.S. swim team. So, with all those things out of the way to begin with. So the first thing I want you to do is I want you to write on your sheet there the common names of these 5 species. And if you need to get up and look at them, you're welcome to do so. And then the next thing I would like you to do is on the rest of that sheet, you can indicate which of those species from, with 1 being greatest and 5 being least, is best in terms of yield, grazing tolerance, digestibility, and crude protein. All right? So feel free to take a look at them if you wish. Some of these people think it a lot more.
Oh, you're kidding me. No.
Well, there was something. It's now the University of Preston.
What is his name again? Just for the records.
It's a university.
You can comment. Yeah, not a comment. I'm not asking for homework. These will not be great.
There's not that. I was wondering, you haven't seen the ad? Did they put the leaf on? It was made for Case.
Where is it? How can you use it out?
Now I have it. So I really have to
Yeah?
make sure the cones not part of the
They
equation.
can add it.
All right, so number 1 is That's right. Number 2, it's a Bermuda. It happens to be Jews. Number 3 is Montreal. Number 4,
Mulatto.
Mulatto. Number 5.
Green.
All right. Very good. So go ahead then with your lists, ranking these species in terms of yield, grazing tolerance, digestibility, and protein. You thought I was kidding when I said you were going to do all the work.
You used to have to spell these correctly and the scientific name.
That's right.
You're being so easy on us.
I've gotten soft in my old age. Some of the more recent students would say that they didn't need to know the scientific name.
What?
Yeah.
No, Dr. Sollenberger, and we had to spell it correctly. Lauren and Colleen, don't you remember those days?
I somehow
What?
Lauren is spelled with that E, right?
I think it's very important that they can spell scientific. I don't know about common names, but I have some real interesting common names.
Just worthless knowledge. Sorry. I didn't mean to say it out loud.
Come on.
Just on camera.
So you're being recorded.
I was just talking about scientific names. That's all.
To a bunch of scientists.
I don't use it.
Andrea's going to have to use her
Give him
editing
his
skills.
coloring book, please.
Yeah.
Okay, how we doing?
We're doing all of them or just you?
Yeah, you gotta do all, Yep. Yeah, the stuff on the back we get to, but just make it less. You don't need to spend a huge amount of time.
You want digestibility too?
Yeah, so I asked for digestibility down there at the bottom.
You are on.
And protein on the back.
We did that first, right? Because we're a little short on time, I'm gonna cut you a little short on time as well and just jump right into it. So the overall objective, in case you lose track of it partway through here, the overall objective, what we're gonna do is to convince you, allow you to understand that if you know something about the plant's growth habit and its physiology, you know a lot about that plant in terms of how it's gonna respond in a pasture. Even if you've never worked with that plant before, right? So a little bit of knowledge will take you a long way. Don't need a PhD, don't need to work at the university for 30 years. You know a lot, simply with a little bit of basic understanding. So that's what we're gonna try to convince you of today and just go from using these plants as some examples. All right, so let's talk about your rankings then in terms of yield. And you can just yell these out, whatever. Give me your one. Marthria.
Vermonter's being the number one.
Okay. So, we get to that, it depends kind of situation, right? And I think if you look at the literature, you can probably argue a number of points here, but I punted a little bit, but I said I put Limpograph, Bermudagrass, and Mulatto as my top tier, all right? And then where would you put Bahiagrass and Rhizoma peanut?
The Hagrass on the bottom.
So Bahiagrass ahead of Rhizoma peanut. All right. So let's talk about that a little bit and figure out what are some of the factors that's kind of driving that response. So why is peanut showing up at the bottom of the list?
Because of the growth habit, it doesn't, it spreads cyclically. Yes, and it's lower in terms of growth or regrowth.
Okay, so we can approach it from a growth habit perspective and say it's more decumbent, it's lower growing, and we said that Bahiagrass may be the next one above it, so those two are sliding down toward the bottom of the overall list, and what they have in common is a relatively low growth habit. We'll talk about why that might be important in just a minute. So what else then would distinguish or set rhizoma peanut plant.
So you,
It is a legume, and because it's a legume, you've got C3. And I think on the pretest, you may have seen a question about C3 and C4, and that relates to their carbon fixation pathway. It's part of the it's a second step in photosynthesis. And what these four have in common is that they are C4 grasses. And C4 grasses are very well adapted. Their physiology is optimized under conditions like what we have out here, 90 degrees, 95 degrees during their growing season. So that's their optimum growth condition. And they are also capable of higher growth because the particular enzyme that fixes carbon first does so more efficiently. All right? So it's a more efficient fixer of carbon. So this plant growing in our environment is in temperature conditions that are somewhat higher than optimum for its photosynthetic mechanism, and that's going to drive down yields. It's their photosynthesis process somewhat less efficient. All right, so we're saying then this one goes to the bottom because of its physiology primarily, and to some extent exposed habit. Then what's going on here then, say, between Bahia and perhaps Lipo that would allow us to say that Lipo grass, even if you've never seen it growing in the field, you would expect this one is going to out-yield that one.
The leaf to stem ratio is higher.
Right? Leaf stem ratio is definitely very different. So Bahia grass is very leafy. To find stem tissue, you either need to look for flowering stems or go to very close to the soil level.
what about rhizoma versus stoloniferous?
Okay, this one has rhizomes, which are underground stems. Lipograss is purely stoloniferous. One of the other factors that tends to be pretty important is that grasses that achieve some height, they elongate stems to a greater degree, have greater capacity for growth and for accumulation of yield. One thing that happens with the head grass, when it gets like this, there's a lot of self-shading going on, all right? And so, yeah, there's a lot of leaf there, but there's quite a bit of leaf in the bottom of that canopy that's doing basically nothing and may actually be a drain on the plant because it's requiring energy to be maintained, but it's not in an optimal light environment for photosynthesis. Whereas lipograss is extending that leaf throughout the canopy. It also has typically at the top of the canopy fairly erect leaves, which allow greater light penetration into the canopy. In the case of the headgrass, it often goes a little floppy, and so you don't have nearly as much light penetration. So that can get you in terms of the growth habit of the plant and how light interacts with the canopy can tell us a bit about growth. All right. Let's talk about grazing tolerance, and with that, I'm going to look at regrowth for just a minute, but so I'll just keep track of my time. All right, so how did you rank them in terms of grazing tolerance?
Bahia has the highest,
Okay.
Spring repeated the lowest.
All right, so we got number 1, number 5. Anybody want to argue with that or kind of play with that a little bit?
I don't like putting a peanut at the bottom of my grazing box because I've seen it in horse pasture situations and it still lives.
Okay.
Yeah, I agree. I had it higher too because of its rhizome system. I mean, it's pretty hard to kill it off unless they dig it up.
Okay. So,
So number 4 and number 5 are up. I just bottom. I guess mulatto can be the least tolerant.
okay. So my list, and again, this one forage guy's opinion, right? So the number one spot was not too difficult to find, right? I put Bermuda grass as 2. And then I actually put rhizoma peanut as 3, and put mulatto and limpo grass in the bottom tier. So, and you know, again, if you disagree with that a little bit or whatever, that's fine. That just my sense, and you know, to some extent depends on what cultivar rhizome peanut you're working with as well, because there are more upright A types and there are more decumbent grazing types. All right, so what are the factors then that drive this tolerance or lack thereof to grazing? What are the key issues?
Carbohydrate storage. Carbohydrate storage, where it's stored.
Okay, so reserves, so it's got to have energy, right? What else?
Ability, meaning that animals will go and prefer and usually use one versus another.
Okay, so give it an advantage to something that's less powerful.
Yeah.
Okay,
What Ed said, the root system.
okay.
Just carbohydrate.
Dr. Blunt would love you, and she's really on a root kick right now, so she would love to hear about roots, right? Okay, so when I talk about a plant responding to defoliation, it's got to have a couple of key things, and one is an energy source, and there are actually a couple of options for where that energy can come from. One of those is, as Joe mentioned, reserves. What else?
This one,
Okay, and that sunlight photosynthesis, and that the only way that works is the plant has leaf, right? Okay, so as an energy source for regrowth, you've got to have either leaf or reserves, or preferably both. You have all the energy you want, but if you don't have something else,
water.
but a plant characteristic, water definitely, that's a key piece.
Well, the root system, root mass is going to vary. Like a legume is going to have a deeper root than grass.
All right, but what's going to allow that plant to regrow?
Nutrient management.
Okay, but a plant, stable plant characteristics. Growing points, all right? So we have all the energy we want, but if we don't have growing points, these are called meristems, zones of undifferentiated, rapidly dividing cells. I tell my college students, they're like you, they don't know what they want to be when they grow up. And they can be anything, right? So they can be whatever the plant needs, so a plant has to have growing points, it has to have an energy source. Right, so as you think about how you manage pastures, those are key issues. Where are the growing points? Where's the energy coming from? What is the impact of my grazing management decision on those aspects? All right, so let's think about this a little bit, and I gave you a question about what is an important factor driving regrowth. And so let's look at that. So general kind of response to, so this is time, and it's time after a defoliation event, and we'll just call this yield. All right? So what would, following a defoliation event, what would be the general shape of that curve? Okay, there's going to be an increasing phase, and so the question would be then, what does that, let's just say if we go here to week 2, what's going to determine if this is our starting point and the amount of mass that's left after the grazing event? What's going to determine whether this curve looks like this, or like this, or like this? Reserves. Okay? What do you think? Okay, stubble height and stubble height as it affects,
Photosynthesis.
which is related to leaf, okay? So during this early growth period, what's really driving the rate of regrowth is the amount of residual leaf. Because if there is no residual leaf, yes, we can use reserves, but those reserves have to be mobilized from where they are. They have to be moved to a growing point. They have to be used to produce new leaf. That takes time, right? So residual leaf is what is driving the shape of this regrowth curve immediately following the foliage event. So with the Bahia grass, so you tell me, would you guess that Bahia grass, we compare Bahia grass and Rhizome peanut, for example, would you guess that after a fairly significant foliage event, that's just a little nibble, which one would have the steeper slope or the faster rate of regrowth during those first 2 weeks? Bahia grass is going to go faster. Rhizome peanut, after a typical hay cut or a hard grazing, there's not a lot of leaf remaining. And so it's going to be fairly flat. It's got a ton of reserves. I mean, try to dig through that rhizome mat, there's a ton of reserves there, but it takes time for those to be mobilized and turn to growth. So the general shape of this regrowth curve is thought to be kind of sigmoidal. And what's going on in this phase is a function really of leaf area. And so if we have peanut, it's probably going to have a considerable lag phase before it accumulates growth and then starts to hit that linear growth phase, whereas Bahia grass is probably going to be more linear from the start.
I'm a little bit confused on that, particularly with Bahia grass. You can make and cut Bahia grass right where there's no green leaf and all that. 2 days later, you've got green leaf because it spurt, it's that growth spurt. Now it slows up until it enters to, I'm assuming, it's converting those energy reserves. But you get that automatic jump in Bahia grass more than I've seen in the other grass.
Right. So where is the growing point?
Well,
And
all
what is elongated? So I told John I was thinking about tearing these things apart. It would actually be a better object lesson for you if I did, but I felt sorry for the people who have to clean up after me, so I won't do that. But if we were to tear this thing apart, and you can do it very easily, maybe I don't know. Yeah, I'm just getting some sheath here, not a rhizome. But so when this thing is grazed, we're not removing growing points. And so the growing point is down here. So the growing point is continuing to, those cells are continuing to multiply and elongate, and it's just pushing that leaf right back up. So you're seeing that very rapid elongation and extension of leaf because there's no removal of growing point involved in that process. Okay. All right. So we got just a couple minutes. I really did make your man. All right. Never approach a woman with a knife. That's one of my life lessons.
You just go in real quiet over here.
All right, let's refocus. Back to the content. So let's talk about digestibility and protein. So what do you have on the top of your list in terms of digestibility? Okay, so peanut and mulatto. All right, so I rated these. Let's see what I did here. So yeah, I put mulatto and peanut basically at the top, and it depends on how you manage this one. This one's going to be very high, almost regardless of how you manage it. Mulatto is going to be driven a lot by maturity, but it has the potential to be as digestible as rhizome peanut, at least in terms of the nutrient value piece of that from the lab. Then I put limpograsс after those two, Bermuda grass next, and Bahia last. All right? And again, feel free to differ with that a little bit. Now let's look at protein.
Why did you put the limpograsс over Bermuda grass?
Just an experience would say that it generally is a little higher in digestibility. I mean, you can, those two are probably a tight cut.
I swapped those two.
Pretty digestible. All right, so protein, peanut, and then after that, I put Bermuda grass and mulatto next, pretty much the same. And then I put Bahia grass, and last limpograsс, right? And one of the other questions I asked you was about the comparison of limpograsss and Bahia grass. Kind of interesting that those C4 grasses have similar physiology, but limpograsс consistently more digestible than Bahia grass with considerably lower in crude protein. And there are some differences among these C4 grasses in terms of, there's some subcategories of C4 photosynthesis. And some of those subcategories are more efficient in terms of the way they use nitrogen. And limpograsс is extremely efficient in nitrogen use, which is great if you're an agronomist and you're buying fertilizer, right? But it throws some challenges at you if you're feeding it to animals, because that efficiency results in low protein. Now, one of the reasons why digestibility of limpograsс is quite high relative to some of the other C4s relates to stem morphology. You look at it and say, man, that's a stemmy, low digestibility plant. But Stan Shank and John Moore looked at some cross-sections of limpograsс stem, even before I got here to Florida. A lot of dinosaurs were still here. And what they found was that the proportion of lignified vascular tissue in the stem of limpograsс is very low relative to many other species. And so stem digestibility of limpograsс in many cases almost approaches that of leaf. And that explains the high digestibility of limpograsss. Even though it's a very stemmy plant, the digestibility of that plant is quite high.
Can you explain again, Dr. So I didn't understand why limpograsss has lower crude protein than the others?
Right, so it relates to the enzymology of carbon fixation. And so the process, there are some subcategories of C4 plants. And limpograsss happens to be within a group that tends to be more nitrogen efficient. And so in terms of C4s as a group, are very nitrogen efficient, but it tends to even be,
efficient from the perspective of needing less.
needing less nitrogen to fix a comparable amount of
Do any of those differences, you said it's different than the other C4 grasses, that also has something to do with the fact that it tends to get an earlier start in spring, earlier in fall when it's cooler, shorter day length, that kind of thing?
Yeah, I mean, I think that issue, I don't know to what degree that relates to that physiology, but it is definitely less day length sensitive. And so I think
So it's more daylight than it is temperature.
I think it's almost assuredly a day length issue. That limpograsс is less day length sensitive. These other grasses, they know when days get shorter, it's time to shut down. Limpograsss, eat, drink, and be merry, for tomorrow I may die, so just keep going, right? And that works well, particularly within a South Florida context. Joe, I've used all my time, so I think you may take one more.
Can I ask one question?
Yeah.
On some of our the newer varieties of the limpograsс,
Right.
the ones that have just been released, the stem cross-sectional diameter is considerably larger than what some of the earlier varieties are. Does that ratio still the same as far as the digestibility?
Yeah, no one, to my knowledge, no one has looked at a cross-section of Kenai or Gibton. But they are tetraploids, like Big Alta and Flor Alta. Red Alta and Green Alta are diploids, smaller stemmed, but more lignified vascular tissue. So even though they have a smaller stem, Green Alta and Red Alta were less digestible than the tetraploids, Big Alta and Flor Alta. So our digestibility data don't show, in fact, they may show a slight advantage, particularly toward Kenai relative to Flor Alta. So I don't think there's any penalty involved in that large stem. Okay, thank you.